Hello friends, today let's resolve the tallest billboard problem. Previously we solved it via depth search, but currently it will cause time limited exceeded. So today we will solve it with dynamic programming. So let's recall what is the question about. We are given an integer array which called rows, and we have to divide it into actually not divide, because we do not need to use all the rows. We can let unuse some rows. So we just need to build two disjoint subsets which they will have the same sum, and we want to make the sum as large as possible. So let's see these three examples. In this example, we can divide it into two sets, and each of them will have the sum 6. So we use all the rows. In this example, we don't use the 1. 2, 3, 5 will be 10, and 4 and 6 will also be 10. For this example, we cannot make it because we only have two rows and they have different lengths, actually heights. So how to solve it? Previously, we solved it by we have two buckets or two sets, left and right. And for each row, we have three cases. One is use it for the left bucket. The other is we use it for the right bucket. The third case is we don't use it. We just try every possible combinations, and we use some pruning, but currently it will not parse the cases. Let's see how to solve it via dynamic programming. We also have two sets, right, left and right, but in this time we distinguish these two sets by which one is higher and which one is shorter. So these are two different sets. If we want to solve it by DP, the most important thing is what is the transition function and what is the initialization. In this case, we have many variables. One is their height. We don't know what is their height, and because we want their height as large as possible, and they must have two equal heights. So how about we just use the height difference? Because in that case, if we use these two sets height difference as the key, then we know our final result will be dp0. That means these two sets has the distance of 0. So that's it. But what about the maximum distance? For this example, if the rows are this, and we know their sum is 12, then the maximum difference will just be 12, because we put their rows in the short set and put all the 12 in the higher set. So this is the maximum distance. So for any rows, we know its size is just the sum plus 1, because it's 0, 1, 2, 12. And for the initialization, we first initialize all the dp to -1, because we want to get the maximum height. And we initialize to -1, and the dp0 will be 0. That means if we cannot make any assignment, then dp0 will just be equal to 0, just like this example. So what does dpi means? I is the height difference between these two sets. dpi is the maximum common height. What does that mean? Actually, when I equal to 0, this dpi will just equal to the height of these two sets, but other cases it is equal to the shortest of these two sets. So it is just the maximum common height, which is the shorter height. So when we have to iterate each row, we have three cases. One is put it on the higher set. One is put it on the shorter side, the other is unuse it. So when we put it on the higher set, what should we change? There will be dpi, is the difference, dpi plus the road, we should to change it. Change it to what? That will be the maximum of this dpi plus road and the shorter height. Why? Because as we said, it's the maximum common height. So when you put that road on the higher set, the height of this shorter set does not change. So it should make sense to the when we update the dpi plus road. This is the shorter one. So what is the current mean? The current is the current state of the dp, because in this part we change this dp. So in order to use the current state, we should use a clone, just like the current screenshot of this dp array. So why is the current I means the shorter one? Because the current I is the distance. Current I just means the maximum common height, which I said many times, it is the shorter height. So when we put the road to the shorter height, what should we update? It will be the I minus road, because we don't know which is higher, which is the road or the shorter one. So we just use distance minus road. So why does it matter? And what should we update? Because when we add it to the shorter one, we should update the distance minus the road, whichever is larger. We don't know whether it's the higher larger or the shorter plus road is larger. So we just pick its minimum, because as I said, it's a maximum common height, so it should be decided by the shorter one. So we just need to compare these two heights. For the higher one, its height is equal to current I plus the I, because current I is the shorter one. Current I plus I, and for this one is just the shorter one plus road, that is current I plus the road. So just pick the road and I minimum. So that's it. We updated it. So this is the transition function. When we put the road on the higher one, we update I plus road. It will become the maximum of this or the shorter one. When we put the road on the shorter one, we update the absolute value of I minus road. It will be this one, or current I plus minimum road or minimum I. Current I plus road is the shorter plus road. Current I plus I will equal to the higher set height. So that's it. Let's convert it to code. So we have to get the sum, and we iterate the road, sum plus the road, and we get the dp. dp, the size will be sum plus 1. Do not forget to do the initialization. Fill the dp -1. The dp 0 will equal to 0. And then for we iterate every road, and then we get the current column will be current dp column. And for I will start from 0, I will less or equal than sum minus road, because the total size of this dp will be sum plus 1. So if we just use sum minus road, we can equal it, I plus plus. If the current I less than 0, we just continue, because that means the maximum height is negative. Otherwise, we update 2. One is we put road in the higher one, that will update dpi plus road, and the shorter one, current I, or dpi, actually mass I minus road, there will be max dp mass absolute value I minus road. The other one will be the current I plus whatever minimum, which will be the I or road. So in the end, just return dp 0. Thank you for watching. See you next time.